Hi, my name is Petr Novikov, and I'm going to talk about taking 3D printing out of the box. Now, this is an average 3D printer. It is a small box with a CNC positioning device inside of it. Now, if you want to print something a bit bigger, what do? You have a bigger box with a bigger CNC positioning device inside of it. Now, what if you want to print something really big, like a building? Do you have a device that is bigger than a building? That would bring a lot of problems, such as transportation or assembling it, and I'm not really sure you can have a span in a CNC that is the size of a Golden Gate. Now, we try to solve it, and in Material Project, we used a robotic arm, a 6-axis robotic arm. It made the working range of the 3D printer much bigger. We also tweaked the material so it cures exactly the same moment when it exits the nozzle, making it possible to 3D print without any support material, which is before was essential in FDM 3D printing. So using a 6-axis robotic arm definitely made the working range of printing bigger. But did it solve the problem of the scale? Can we use a robotic arm to print buildings? No, we can't. We didn't solve it. You will still, if you want to print something the size of IKEA, you would still need a huge, gigantic robotic arm, something like a robotic crane, which, so far as I know, does not exist. Now, how does a positioning device for 3D printing that is independent of the scale of the object that it prints look like? How a universal robot that can print basically anything would look like? Now, we worked on this concept for past 8 months, and this is an idea of a community, an ecology of small robots that can 3D print virtually any size as long as material can hold it. Now, we have several types, and each one of them does different jobs. What you see here on the top is the supplier. Basically, it just rolls around driving material. Here in the bottom, you see the first robots. There, they have tracks, and they have a vertical 1-axis CNC positioning device, and their job is to print the footprint of the building. First, 10 inches of the building. Now, why would you print just 10 inches? Because then you put the second robot of the team, which basically clamps onto the structure, and it rides back and forth or continuously, printing it layer by layer. And the cool thing about it is that it attaches to the layer that it has just printed. So you can print basically infinitely. And the grip of this robot is so strong that you can even print horizontal structures like ceilings. But then you would end up with a shell that is just 1 layer thick. That is not strong. It can't be a building. So what do? You have a third robot, which has a vacuum generator, which is attached onto this surface, and it goes and prints layers on top of it, making it thicker. And also, the interesting thing about it is that it shouldn't print only horizontal, parallel to each other layers like it's usually happening, but it can print free-form layers however you want. In this project, we used a material that is 60% cement powder and 40% polyurethane. But I want to show that you can also use indigenous materials, as we did in Stone Spray project. Here we used, basically, we still use the robotic arm because it was done 3 years ago, but we used the material from the site. So the robot would suck the soil from the site and then spray it together with a binder. And there would be 2 jets that would meet in the air and mix in the air, so the material would land already mixed. And in 2 days, these structures become rock hard. So we think that with this technology and with this material, you can print something like a bridge, and it would look like this. Now, this is all academic work that we have been doing in the past 4 years, but we have started a company in San Francisco that is going to take this research further. Thank you very much.